And in lesson 16, we're going to review 3 unrelated topics. Should go pretty quickly so that we'll still have some work time. We're going to be looking at complex fractions, abstract equations, and division of polynomials. So starting off, here's a complex fraction. And we've already been doing some of these. Who can tell me what you would like to do as we start off trying to simplify this thing? Come on, somebody's got a good idea. What should we do to simplify this thing? Maya. Because m squared r is the least common denominator. We don't need m cubed. M squared is enough to cancel out all of the m's when we multiply numerator and denominator by m squared r. So we are distributing when we multiply m squared r times the first term of the numerator, the m squares cancel, and we have r times t. When we multiply m squared r by the second term in the numerator, one of the m's cancels, and we have mrw. And check my work, don't let me go on if I get any mistakes up here. For the denominator, we also need to distribute. The m squared will cancel when we multiply by the first term, and we will just have rx. And for the final term, one of the m's cancels and the r, so we have my. Does that look right to everybody? Okay. You must at least do a mental check. Is there a GCF that I could factor out? Or can I factor numerator or denominator as parentheses times parentheses to see if you have anything that cancels numerator and denominator? So I look at this denominator and there's nothing I can factor. So I could say that's my answer. I could also say, what is the GCF of the numerator? So I could factor an r out of that and be left with t plus mw, but there's still nothing I can factor in the denominator. Since nothing will cancel, I will accept it either way. But you've got to at least check. If there is a factor that could be canceled and you don't find it, it is incorrect. Does that make sense to everybody? And if you guys will try to put things in alphabetical order as much as possible, it'll make the checking go faster. I'm not going to count off for that, but it will make it a little bit faster for us. All right, let's go to a harder complex fraction. Harder because this doesn't just have a fraction inside of the fraction somewhere. It has a complex fraction inside of the fraction. So what we're going to do is we're going to use that method just for what I've put the red box around. Then we'll do it again to simplify the whole thing. So for right now, we are going to leave the y in the numerator and the f plus in the denominator just like they are. So what do I need to do to simplify that k over x plus m over w? What do I need to do to simplify that? Somebody who hasn't already answered. Or I can just start calling on people. Chloe. So what am I multiplying numerator and denominator by? So w over w. So numerator is easy. We get kw. But now we need to distribute this w times each of these terms. So we get wx. And then when we multiply the final term, the w's cancel, and we have plus m. Everybody with us to that point? Okay, now we just have one regular fraction inside of the regular fraction. So now we go back to the method that we're used to, and we multiply numerator and denominator by wx plus m over wx plus m. But we have to be careful. There's plenty of places to make mistakes in there. So numerator, we are distributing. And we have wxy plus my when we distribute that y. That's the easy part. Now, for the denominator, first we need to take this wx plus m times the f. Then we need to take the wx plus m times the red part, and the entire denominator cancels out, and we have kw. We're not quite finished, but want to make sure we're tracking to this point. Okay, we still need to distribute f times that wx plus m in the denominator, so we have fwx plus fm plus kw, and we have wxy plus my in the numerator, and double check that that looks right. And we do have a GCF in the numerator. We could factor that out. Do we have a GCF in the denominator? So we could just stop with this. So any questions with simplifying those complex fractions? Okay, then let's move on to our abstract equations where we're solving for a variable, and you got a little bit of a review for this with those trig problems number 14 and 15 on that worksheet that I gave you. First step, distribute if there is something that you can distribute. We avoid some mistakes if we go ahead and do the distributing first. So this tells us f is at over x plus jt over gy. What do we need to do next? Next step. Okay, you remember next step? Well, how do I do that? So I'm going to multiply everything by the least common denominator, which is gxy. Need to be sure we remember that that's on both sides of the equal sign. So we have fgxy equals, then the x's cancel, so we have agty, I think. Check me on that. And then the g and the y cancel, so we still have the x times this, so jtx. Yes?
So when you're multiplying with the denominator, why aren't you doing x plus gy? Like when would you do x plus gy?
If I had one denominator that had x plus gy in it. These are separate denominators, and if you think about numbers, you don't add one denominator to the other denominator to get a common denominator, and we don't here with variables either. Any other questions before we go on? Okay, what's the next step? I need a next step in here. Elizabeth. Okay, so we're going to, why g? So we're going to move all g's to one side. Because g is the variable we're solving for. So that means I can keep this fgxy, but I need to subtract agty because those are my ones with g's, and that will equal jtx. Next step, Ryan. We factor the g out, I think is what she meant there. So factor out g. So we have g times fxy minus aty equals jtx. And final step, what do we still need to do in order to finish this up? See, Avery. So we divide by whatever we had in that parentheses after we factored out the g. So that means that our final answer is G equals JTX over FXY minus ATY. Everybody good on up to there? Okay, that just leaves one other topic for us to review today. The other thing we're going to review is polynomial division and how you can tell when you're done if you got the correct answer. So divide x cubed minus 2x by x minus 1 means that I have x cubed minus 2 on the inside and x minus 1 on the outside. Now I gave you a hint with the way that I wrote that. What else do I have to do as I set this up? Chloe? Put the placeholders in, so plus 0x squared and plus 0x. Does anybody remember how I get the first term of my quotient? How do I come up with what that needs to be? We're going to look at the leading term of the dividend and the leading term of the divisor. And we are going to think, you don't have to write this down, what is x cubed divided by x? Because we're trying to put something up here, so when we multiply, this is going to cancel and go away. So everyone, what does this equal? So we put x squared up here. How do I get the next line? We multiply what we've put in the quotient times the divisor. So x squared times x minus 1 gives us x cubed minus x squared. Now think about what you're doing when you have some number in here and then you get some number up here. What do you do to get, if it's long division with numbers? You get this, and then what do you do with that row? You need to subtract. So we are still going to subtract on that row, which means we change all of the signs. And the x cubes cancel out with polynomial division. If you're doing it correctly, the leading term goes away with each step. So we now have 1x squared plus 0x minus 2. So now we need to come up with the next term. So L, what will be the next term of my quotient? Okay, so I need a plus x because I'm looking at this leading coefficient and the leading coefficient of the divisor. X squared over x is x. Multiply, and I have x squared minus x. Then what do? Subtract, so we change all of the signs, and we have x minus 2. Now what? Kinsley? Because we look at this x divided by that x in the quotient, and we have 1. It's a positive 1, so we say plus 1. We multiply, and we have x minus 1. Subtract that row, and negative 2 plus 1 is negative 1. So we need to take that remainder. Since it's negative, we put a minus sign, and then we have the 1 in the numerator, and our divisor, x minus 1, becomes the denominator. So this is our answer. Everybody good on that? Okay, there are two ways that you can check these. And I'm going to, so I'm not going up and down all the time, I'm going to recopy that we had, what was it, x cubed minus 2 divided by x minus 1. And we got x squared plus x plus 1 minus 1 over x minus 1. So the book does it where you check by taking your quotient, and then you get a common denominator. So that would be x squared times x minus 1 over x minus 1 plus x times x minus 1 over x minus 1 plus 1 times x minus 1 over x minus 1. And then that remainder term, minus 1 over x minus 1. So then we've got the common denominator of x minus 1. Do you have a question? So then we have x cubed minus x squared plus x squared minus x plus x minus 1 minus another 1. The x squares cancel, the x's cancel, the 1's combine, and we have x cubed minus 2 divided by x minus 1, which is what our original problem was. So that's one way to check. Second way that you can check, when you were learning division with just numbers, you learned that your quotient times your divisor should give you your dividend. And so we could do the same thing. We can take the x squared plus x plus 1 minus 1 over x minus 1, there's our quotient, times our divisor. So that's going to give us x squared times x minus 1 plus x times x minus 1 plus 1 times x minus 1. And then for the final term, we'll cancel the denominator and we have another minus 1. And then a similar series, x cubed minus x squared plus x squared minus x plus x minus 1 minus 1. The x squares cancel, the x's cancel, and we have x cubed minus 2, which was our original dividend. Now, we didn't make you do the checks last year. I'm not going to require you to do the checks this year either, on homework or on the test. But if you've got time on a test, it's a smart idea to know how to do it, to make sure you got it right and you get those points. On homework, if you aren't sure if you're doing it right, this would be something you could do to check yourself. So I wanted to model it so you have that ability, just as something that can help you guys out. Any questions with what we have covered today?